Today we're going to talk about the volume of solids created with cross-sections by Anna, Allie, and Erin.
Cross-sections are shapes perpendicular to the xy plane that allow us to find the volume of a given area. Chord length is a distance between two bounds that will typically be the base of the cross-section. In the pink you can see that's the chord, and in the green it's the cross-section, the actual triangle.
First, find the chord length of the graph given that it is either perpendicular to the x-axis or the y-axis. To find the chord length with respect to x, do the top function minus the bottom function. And to find the chord length with respect to y, do right function minus left function.
After you find the chord length, plug it into the area equation as the base value. The area is based on the shape of the cross-section. Here are some examples. When finding the area of a square cross-section, you do base times base. Since the base is equal to chord length, your area is the chord length squared. When finding the area of an equilateral triangle cross-section, you do the chord length squared times the square root of 3 divided by 4.
When finding volumes of solids with cross-sections, you need to integrate the area of the shape. But first you need to find the bounds.
To find the bounds of the graph, set the two curves equal to each other. If the second curve is an axis, set the function equal to 0. Once you have found the bounds, you are ready to integrate.
Let's try with an example. Y equals the square root of 36 minus x squared. Side note, when using square roots, you need to use the negative version too, so negative square root of 36 minus x squared.
In this case, we will find the chord length with respect to x, so we will do the top minus bottom. The purple square root of 36 minus x squared is the top version, or the positive version, and the green negative square root of 36 minus x squared is a negative version. We will be doing top minus bottom, so subtracting a negative turns into a positive, and that equals 2 times the square root of 36 minus x squared.
Now that we have the chord length 2 times the square root of 36 minus x squared, we will use a square cross-section in this example. First, you plug 2 times the square root of 36 minus x squared into the area equation for a square as the base or the side length. So area is equal to base squared, and your base value is 2 times the square root of 36 minus x squared. So your area is 2 times the square root of 36 minus x squared squared.
Bound it. To find the bounds, we must set the top and bottom equations equal to each other, as shown here. Then we will square both sides to get rid of the square root. Then we distribute the negative. After that, we add 36 to both sides, and that will cancel this out. Then we add x squared to both sides to cancel this out. That'll give us 72 equals 2x squared. Then we divide the 2 to try to get x by itself. That'll give us 36 equals x squared. Then we take the square root to get x by itself. X equals plus or minus 6. Our bounds are 6 and negative 6.
Now we integrate to find the volume. You can use your calculator to find the answer to the integral that is negative 6 to 6 of 2 times the square root of 36 minus x squared, all squared dx. And that answer is
1,152 units cubed. Your units are cubed because you're working with volume.
Thank you.